Alright guys, welcome back. So today I have a really fun project for us. I've been looking forward to this one for a while. So we're going to be making a foundry. Now if you don't know what a foundry is a furnace that gets really hot. It's typically used for like melting metals down so you can pour them into casts and dies and different things. My definition of really hot is 1000 degrees Celsius, which is about 1800 degrees Fahrenheit. So that's the temperature we're going to be trying to work with. That should let me work with most of the different grades of aluminum that I want to work with. Yeah, it should be really awesome. I've tried this before. Turns out 1000 degrees is quite hot and really hard to get to, really hard to sustain. It's hard to find materials that just don't burn or melt or break at that temperature. But I think I've got a really good plan today, so we're gonna give it a go. I get a lot of questions about why do I want to make one? Why do I want to do this? I've got this 3D printer behind me, and it's really cool. You can make all sorts of different things with it, but the problem that I run into with it is that the things that I make are pretty easy to break. Right, it's pretty easy to expose them to too much force or just too much heat. I mean, especially I live in Florida. Like if you print something and leave it in your car, it's gone already. So if I could actually make things out of metal, that would help a lot. Other than that, I really like metalworking. I think having a foundry in the backyard would be kind of cool. I mean, not literally, but you get the idea. Other than that, I think the biggest question I get is, what am I gonna make with it? What's the first thing I'm gonna do with it? And honestly, I have no idea. I've gotta make the foundry first, and then I'll probably spend a good chunk of time just learning how to use it, how to do metalworking, and then I'll know what I wanna make with it, and I'll actually be able to use it for stuff. So you kind of just gotta jump in and figure it out with these sorts of things. But like I said, I know I have problems in the past that would be solved with it, so I'm sure I'll come up with some use for it. But yeah, this will be fun. Let's dive right in. The first step in any of these projects is to come up with a bill of materials that I know what the hell I even need to go buy. And in this case, I know that I want to make the foundry this time out of fire bricks, but I need to figure out how many, right? It's going to be like 4 bricks, maybe closer to 5, not really sure. So I pulled up Fusion 360 and decided I'd make a really quick CAD model of what I wanted to build. So I started off by punching in the common brick measurements and just laying out a pattern in a layer. And I figured out that I was going to need 8 bricks per layer, punched in the thickness, figured out how tall I wanted it to be, and figured out that I needed 8 layers, which is kind of convenient. So 8 bricks times 8 layers is going to be 64 bricks. Throw in some tolerance, we'll buy 70 bricks. Works for me. So I pulled up the inventory of the nearest hardware store, and they did have fire bricks, but the measurements were slightly different. So I went back into the model and changed the parameters for the size of the bricks and verified things were still good. And this is where it's super nice to actually have a parametric model that captures intent, because I literally just changed 3 text fields, hit a button, and it recalculated everything based on the new sizes, and I made sure it was still good to go. So that was really exciting. More interestingly, I realized that 70 bricks is almost 270 pounds, which is a lot more bricks than I thought it was gonna be. I didn't realize that bricks were like 4 pounds each, but it, checks out once you think about it. Anyways, so with the bill of materials in hand, I drove down to the store, and about halfway there, I realized that I'm an absolute idiot because I need 64 bricks to actually build this thing, throw in a couple extra just for tolerance in case a couple of them break, and I needed to buy 70, but why would I buy 70 bricks when I could buy 69 bricks? Like, come on. So got to the store, pulled in, ran inside, super excited to go buy 69 bricks. I was thinking, I don't know what I was thinking. It just seemed fun. So I went down to the masonry aisle, figured out where fire bricks were supposed to be, and they didn't have any, which is really strange because online they assured me that they had several hundred of them. So I'm not sure what changed between me leaving to go to the store and me getting to the store, but that was disappointing. So I walked down the rest of the masonry aisle, and all they had was concrete block. So I don't know what the heat tolerance on concrete block is, but we're about to find out. So I found a couple of shapes that would work for the foundry, one that was actually gonna do a pretty good job of holding the burner, and stacked them onto my cart, brought them out to the car, and loaded my car up with probably still close to 200 pounds of concrete blocks, and drove home. It was a really fun drive home because it looked like you're playing a game of prop hunt, but your friends just couldn't find any decent hiding spots, so they all chose to be cinder blocks and piled into the same car. It was kind of ridiculous. So once I got the blocks unloaded from the car and pulled out into the backyard, I started by chiseling away at the one that I said was going to become the holder for the burner. It was almost perfect, but just not quite. The burner had some wobble. So I busted my hammer and chisel out and just basically chipped away at it enough so that it actually became a really, really nice sturdy holder. And I've never done like sculpting or anything like that before, but it was actually quite satisfying just to like slowly chip away at this thing and make it the perfect shape. It was almost cathartic. It was awesome. Like surprisingly 10 out of 10 would recommend doing that again. Less 10 out of 10 is the Florida heat. And unfortunately all of the rest of the footage of this was lost to the heat when my phone overheated, because while I'm sitting there in the sun doing manual labor, my phone could not just sit there silently in the shade and watch me, so I guess you find out who your friends are. Anyways, it was really not a lot more to it. It was mostly just stacking and arranging and assembling the Foundry out of all of the blocks that I had bought from Lowe's. Just basically like Minecraft in real life. But, you know, after I built what I had bought, I decided that I wanted it to be one more layer higher because ultimately what was now holding the burner was a little bit higher off the ground than it was originally going to be. So I went back to Lowe's, bought another couple blocks, brought them back, and built the final layer. So that was really good. So with the Foundry fully built, this is where things really start getting fun because we need to put it through a series of tests that I call heat trials so that we can make sure that it's actually functional, right? We need to figure out things like, will the concrete blocks crack if I heat them up too quickly? Will they crack if I cool them down too quickly? Will they crack if they sustain temperatures for too long? Can they even hit the 1,000 degrees that I'm going for? Can the burner put out that much heat? Do they need insulation to like really efficiently and effectively hit that temperature? We need to answer all those questions and then some. And heat trials is basically a series of tests designed to answer those questions. We're gonna aim for 250 degrees Celsius, get there pretty quickly, sustain it for a while, cool it off, do some inspections, and then rinse and repeat at 500 degrees Celsius, and then at 750 degrees Celsius, and at 1,000 degrees Celsius. And we're gonna figure out what the best procedures for all that is. Because from a safety perspective, if you were to buy something like this online, you'd expect it to come with an instruction manual, and this would be a pretty important instruction manual to read through. And I built this thing yesterday, so there is no instruction manual for it. So the heat trials also provide us with a safe sort of environment to figure all of those things out, right? We're going to start at lower temperatures than we would actually be working with, which is really nice and gives us an extra, you know, safety margin to learn with. And we're also not going to have any metal in the Foundry, so we don't have to worry about weird edge cases like metallic fires. So I think we've got a pretty good safety environment, but just to make sure we're being as safe as possible, I manufactured this sign for myself, which, you know, generally pretty good advice. And it turned out really well, if I do say so myself. I'm gonna go hang this thing up behind me and we'll go figure out what this Foundry can do. At least I wanted to see what this thing could do, but it rained for several days because it's Florida in the summer, and that's what Florida does best in the summer. But eventually I found a day where it wasn't raining and I had enough time to really make this happen, so I sat down and got to work. First challenge was actually just lighting the thing. All I had were matches, and it took me several attempts to really settle on something that worked. But once I could do that, the next problem was trying to find the right ratio of air to gas, and then the amount of that ratio to really put into the Foundry. That took a good bit of playing around with, and eventually I thought I had a problem where the gas wasn't getting enough oxygen to burn, and the idea behind that was that there were some violent pops that were happening every so often, which I thought was a whole bunch of unused gas suddenly just almost exploding, and the temperatures being super low as a result of not burning all of the gas that I was putting in there. So I started pulling the Foundry apart brick by brick, because the more you pull it apart, the more it becomes just an open flame burner, and open flame burners should have no problem getting oxygen. But I found that the more I pulled it apart, the more my temperatures didn't change at all, and I still had the popping issue. So after a little bit more inspection, I figured out that the popping is actually caused by pre-ignition inside the burner. Basically, the mixture is too lean, so when the propane enters the burner and mixes with oxygen, it's hot and lean, so it just immediately goes off inside of the burner, and the flame goes out because now it's all burning inside of the burner, and that's also not conducive for heat transfer or efficient burning, so it's kind of a problem. Thankfully, that's very easily mitigated just by making the mixture a good bit richer, and then it doesn't happen anymore. And the low temperatures I eventually attributed to heat loss. While the inside of the foundry was 140 degrees, the air pockets inside of the concrete blocks were actually hitting 100 degrees, and I think ambient temperature was somewhere around 27, 28 degrees, which means that that's a lot of heat loss. So on the upshot, I think if we add some insulation, we'll be in a really good spot. Downside is I have to buy insulation, wait for it to show up, so that brings us to an abrupt end to the first round of heat trials where our maximum temperature is 140 degrees, so gonna have to work on that. So came back in here, sat down at my computer, did some research on different insulators, took a look at what my hardware store could order for me, took a look at what I could order online, went through some blacksmithing forums, eventually settled on a material called ceramic fiber, which is a super high temperature, high quality insulator. Eventually found a company that would sell it to me, so I went through their SDS, which is the safety data sheet, which is a really handy piece of paper. It basically tells you, hey, here's all of the risks that this poses to you. It ranges from things like, hey, it's not combustible, which for insulation going inside of a foundry, that's a generally good property to have. Doesn't react with acids or bases, no real notable chemical reactions. And the biggest health risk is that it's a contact irritant. So basically just wear long sleeves, gloves, and some goggles, and you'll be good to go. All in all, pretty tame. Decided to buy 40 pounds of it. So yeah, that should show up here shortly. Oh, hey, let's go see what's at the door. Oh, hey, look, it's 45 pounds of ceramic fiber. Just what I needed. So yeah, the first thing I did was take some measurements, and I cut a little rectangle out of the bottom corner of the blanket. That's where the burner is actually gonna kind of come through it into the foundry, and then it was super easy just to kind of line the walls with it and slide it down into place. Done. The second part was a whole lot more tedious. I had to take the kind of top layer of bricks off and pack the walls with insulation. Just grab a handful and drop it in, and grab a handful and drop it in, and another handful and drop it in, and pack it down some, and just fill the entire wall of the foundry with insulation, one handful at a time, Actually, because, number one rule of storytelling is you want your audience to feel like they're with you in the story. So I tell you what, how about you guys close your eyes, and I'm going to describe this to you, okay? I'm just going to set the scene. So, you've been working already for about 20 minutes. It's really hot outside, about 100 degrees out, 37 Celsius, depending on what part of the world you're in. And you're just going, one handful at a time. Grab it out of the box, drop it down, grab it out of the box, drop it down, and suddenly you feel that familiar feeling where a mosquito lands on you, and you go to brush it off and swat at it, except that, your gloves are currently covered in ceramic fiber, which is a contact irritant. So, if you actually touch your skin, you're going to make it a lot worse than a mosquito bite. Nothing worth going to a doctor over or anything like that, but definitely really irritating. So, you sit there and you're like, all right, well, I guess I'm just going to rush through this to get it over with faster because I'm just out here getting eaten up, except that if you don't do it right this time, you're just going to have to come back and do it again. So it's really better if you just take your time and try to ignore all of the buzzing around you. And, maybe you can distract yourself by liking and subscribing this video, since I had to put up with all that. But yeah, after that, it was basically just time to clean things up. So I collapse the boxes, set them off to the side, put a tarp over the top because, the number one rule of doing weird shit is don't be a dick about it. And the last thing I want my neighbors to think is that I just have insulation sitting here in some weird stone wishing well thing in my backyard that's going to blow into the air guard. So, throw a top over it. Now they don't even see it. If they know what it was, they'll hopefully think that a tarp is good enough to keep it in. And in all honesty, that stuff is super heavy. It's not really going to be a problem. Yeah, kind of have a foundry now. Okay, so before we start heat trials, I did actually finish the top of the foundry with bricks. And now that I've done it, it looks really nice. It actually looks like a foundry. Comparing this to what we started with, it's kind of hard to believe that actually would have worked. But here we are, wiser than we were before, so let's do this. Heat trials round 2. Let's see if we can't beat 140 degrees Celsius. So right off the bat, obviously we have to get this thing going. So the best ignition process I had coming out of the last one was to make sure that the gas valve was closed, and then open the master gas, fully close the mixture, and drop a match in, which apparently lighting that match is the hardest thing in the world for me because I could build the rest of it, but I still can't light a match on the first attempt to save my life. Once I finally did do that, all you gotta do is then go open the gas 1/4 turn, gives you a nice smooth ignition, really awesome, and then adjust the mixture for a nice blue flame instead of an orange flame, and you're good to go. And oh my god, we just casually hit 800 fucking degrees Celsius just from doing that. I'm kind of mind blown at that. That is so hot to have just hit with the ignition procedure. It's absolutely awesome. A whole lot less awesome is leaving the box of matches on top of the Foundry. I can't believe I did that. I mean, kind of in my defense, I didn't think this was going to work nearly that well, but come on, that's still an awful look and a really bad defense. But moving on from that, actually getting the temperature down to 250 was really quite difficult. I kept pulling gas out and, you know, incrementally got lower and lower and lower temperatures, but about 400-ish degrees, I couldn't pull any more gas out because the flames would just die. So I eventually settled on getting it as low as I could and then adjusting the mixture to actually be less efficient in order to drive the temperature down even further. But I did eventually hit 250 degrees, and I held it there for 10 minutes and then let it cool and kind of took things apart a little bit, inspected it, made sure things were still doing good, and then kind of went through the whole process again, but instead I drove it only down to 500 degrees Celsius. Still weird to think that I'm driving it down to 500 degrees Celsius, but that was a lot more straightforward. Held it for 10 minutes, then turn it off, let it cool to inspect things. 750 degrees is arguably the easiest because ignition basically leaves you right there. So it's just a matter of fine-tuning it a little bit, holding it for 10 minutes, again, cool it off, inspect it. And then the real test is 1000 degrees Celsius. So yeah, this was the fun one. So yeah, tried to get it up to about 1000 degrees Celsius for like 20 or 30 minutes. At one point I got it up to like 950 and then it just cooled back down to 900 and I really just couldn't break that barrier. I got to a point where I was adding quite a bit of gas and it just felt inefficient and felt like I needed to try something different. So put it out, let it cool off, kind of inspected things a little bit more, made sure it was good, and then lit it back up and held it at about 500 degrees as a pretty decent reference point where I kind of just started playing with the mixture, playing with the gas, playing with a couple different things. And what I eventually found was not surprising at all, but the blocks that I have at the top that I can open and close actually serve as an exhaust valve, so to speak. The more I open them, the more air I let out, which is unfortunate because you're losing heat. But if you close them all the way like I had it, it's also super inefficient because, you know, when you try to add in new propane and oxygen, there's already a lot of air in there and it just doesn't take very efficiently to it. So I found a way to get the right amount of opening, basically as small as possible, but enough air can escape that you could replace it with fresh fuel, and it made things so much more efficient. Hit 1000 degrees, actually got up to 1050 degrees and had to work on cooling it off a little bit more and really just fine tuning in that 1000 degrees Celsius number. It's so hot that everything is like really delicate. You change one thing and you might be off like 40 or 50 degrees, but got it to balance like right in there, plus or minus like 20 or 30 degrees. It was awesome. I think another really big thing to note there too is that as it's heating up, there's a lot of temperature instability, and after about the 10-minute mark, things kind of evened out a whole lot more. Hit 1000 degrees and held it for another 10 minutes and powered it down, let it cool off, gave it one last round of inspections, and called it done. So that is a 1000 degree Foundry right there, which is pretty impressive, not gonna lie. I wasn't really sure I would make it the second time either, and it's awesome to have been there. But I decided to melt something just for funsies because I can't really just show you guys a video of this like gray brick Foundry with a thermometer sitting on top of it and call it a day. So went and grabbed a can of White Claw and dropped it in there, and it actually gave us this really awesome fireball. Metal typically burns when you melt it, which is actually a bad thing because it means that it's oxidizing, but I've never seen a system system that was so hot that when you dropped a can in it, it shot a fireball up out of the mouth of it. So that just looked awesome, but it also highlights how much I have to learn still because it left me with absolutely no aluminum and just entirely slag. Thank you guys for coming on this adventure with me. I can't wait to show you guys what I build with it. It'll probably be a little bit because, like I just said, I've got quite a bit to learn. I've got to kind of figure my way around metalworking a good bit. I'm hoping to be able to do some lost wax casting with this guy, which would be awesome because then I can like 3D print some gears and hopefully cast them into metal. But really just have to do a lot of tinkering to really get the process down before I'm comfortable actually fabricating stuff with it. I think a lot of people jump into that stuff too early and they like don't play around with a new 3D printer, play around with a new thing before they start trying to do stuff with it, and they just get frustrated when they can't quite do stuff with it because they're trying to build a project, but they're inadvertently having to learn at the same time. They don't really want to learn because they want to do the thing that they're doing. So probably gonna take a couple months and really just hone my skills on it and get it to a point where I can comfortably and repeatedly work with it. But yeah, this definitely isn't the last you guys will see with it, but yeah, that's all I've got. So I hope you guys enjoyed it and have a great day. And if it's Friday, have a great weekend. Catch you guys in the next one.